All right. Good morning, everybody. My name is Eric Johnson. I am with Adams Columbia Electrical Cooperative, and we're here today to talk about electrical safety and the hazards that you guys may encounter out there working in road right-of-ways, on the roads, doing construction. I brought with me today Ryan Yankee. Ryan is, I'm guessing you, oh yeah, I know how you know him. Ryan has been a lineman out of our Watoma office for 10 years? 10 years? Yep. I've been with the co-op 15. 12 of those years I was a lineman with Ryan in Watoma. So Ryan has seen a lot of good experiences out there. You get to see some interesting stuff. And we're hoping to share that with you, what we've seen, the hazards. And just because something seems obvious out there, I want you to remember not everything is as obvious as it looks. So there's a lot of hazards with electricity and how our equipment works, and it works right, but there are situations where things may stay hot when you think they're not. So today we're going to go over overhead lines, underground, step and touch potentials, and then Mother Nature, generators, and renewables. The last topic there is a growing concern between YouTube, makeshift DIY type stuff. People have gotten very handy at being able to rig things up and energize things that they didn't know how to do before. And there are ways that they can backfeed our lines and put you guys at more of a risk, along with our linemen too. So we'll cover how that's done and why you need to avoid certain things. 4 big takeaways from this presentation. Always want you to remember that electricity wants to go home. It wants that easiest path to ground. If you have power lines on your vehicle, that could mean is going through the frame of your vehicle, through the tires. But then say you try to exit that vehicle, you may be a better conductor than going through the tires. So it's trying to find that easiest path to ground, and we want to keep you from being that easiest path to ground. Also remember that it's amperage that really does the killing, not the voltage. So high voltage, obviously there's a lot more stigma with hazard, right? 69,000 volts, 138,000 volts, and up from there, those transmission voltages, they get a lot of stigma, definitely dangerous. But that doesn't mean that 120, 240, 480, those secondary voltages, they can also pose a real hazard to you and to our linemen. And our system runs on 7200 single phase. So that means phase to ground. We're 12,400 from phase to phase. Those are voltages that are not transmission voltages. They don't have that stigma, but they are definitely enough to do damage to you, your equipment, and bystanders in the area. So we want to make sure that you understand how hazardous it actually is. Situational awareness. This is something that this is going to help keep you safe the most, probably. Being observant, seeing what you're working around, making sure you're keeping your clearances, and then when you get into a situation where you're working at the same location every day, day in, day out, I want you to keep that situational awareness, because there are little oddities that can happen. Things can happen, somebody could hit something, and what it can actually do is put other people on the crew or the public at risk if something changes on our poles. If our clearances, all of a sudden, we lose our clearances because something got hit and it's a little bit lower. That thing you drove under 100 times already might not be at that same height. So that's where situational awareness is going to be helping you. And then if you do have a situation where you have electrical lines down, who should you be calling? One, it's risky, so 911 is not bad to call, all right? But even firefighters, EMS, police, all law enforcement, what are they going to be able to do? They're just going to be able to keep people out of the area, right? You're also going to need to notify the electrical utility. And we want to give you some tips on how you can best inform us on where the problem is so that we can get to it as quick as possible. So our first video was published this year, and it does a better job talking about how electricity is generated and gets to your home.
How to open your car door while submerged underwater.
This is not the video.
Flaw in all
It's coming.
Have you ever flipped on a light switch in your home and wondered, how does electricity get to my home? Let's take a look into how it all works. From the power generation plants to turning on the light switch at your home. It all starts at a power generation plant, whether that be coal, natural gas, solar, or any other source of energy. The power plant turns these fossil fuels and renewable resources into energy through an extensive process. The power they generate gets distributed onto transmission lines. Transmission lines carry electricity in long spans to get power to thousands of people. They're the massive electric structure carrying thousands of volts of electricity you may see along the interstate or across country. So how does the electricity that is on the transmission lines get stepped down to serve a single home? That's where substations and distribution lines come into play. Electricity from transmission lines feed into our substations. Through many pieces of equipment within our substations, voltage is stepped down to a level that is more suitable for the needs of our membership. Once the electricity is at a level that our distribution lines and equipment can handle, power goes out onto our lines and on its way to homes, businesses, farms, and other electric services. Whether you have an overhead or underground electric service, power gets converted from high voltage to a voltage needed for your home through our transformers. You may see transformers as cylinder-shaped equipment on our poles or a green box in your yard. From the transformer, power feeds through our meters to a breaker panel in your home. Within a breaker panel, there are a variety of switches that indicate where power is directed through your home or business. Power travels through the electrical wiring in your home all the way to the light switch. We hope this high-level explanation helps you understand how electricity gets to your home. If you have any questions, give us a call at 800-831-8629.
All right, so that was a general overview on how electricity is generated, then it hits transmission. From that transmission, it goes to substations, and at that point, it gets stepped down to that distribution level of voltages. So on our system, if you just pause it, right? Okay. On our system, like I mentioned earlier, we run 7,200 phase to ground and 12,400 from phase to phase. So obviously the higher voltage, if you would get between two phases, is more hazardous. There's more energy there. But 7,200 phase to ground is more than enough to do some serious damage. When you're out there working and you see overhead power lines, we're going to start on the top of the pole and work our way down. On the very top, is that there? Oh, cool, I got the laser this time. So on the very top, we're going to start with our conductors. So these on the very top for our system is going to be our phases. This is three phase because there's three wires on the very top. In between each of them on our system would be 12,400. From those wires down to the next wire down, which is their neutral, each of those would be 7,200. Now when you're working and you're trying to keep your clearances, I want you to remember not to just keep your clearance around these phase wires, but also treat that neutral as a current carrying conductor. That is something that we need to maintain clearance from. Because if that neutral would break, and then you would get in between both ends of that, if there was any amperage running on that, which there can be, you would have that current go through you. And what did I say earlier? It's not the voltage that kills, it's the amperage. So it may have low voltage, but it can have substantial amperage, depending on the situation. But just remember that that neutral is also a current carrying conductor. In some areas of the state, on older lines, I want you to be aware that that neutral and those phases are actually reversed. Sometimes the neutral is on top and the phase is below. And the rule of thumb I was told years ago was that was an idea for lightning protection. It must not work that good because nobody builds line like that anymore. But that phase was low, so then what you would consider the most dangerous part, that phase, running 7200, would be lower on that pole, closer for you to make contact. So that's why no matter what, neutral or phases, treat this whole area with the same amount of respect and keep your clearances from that. Moving down from our phase and our neutral, we have our transformer. Here is an overhead transformer. It's a gray cylinder on the side of the pole. If you see them on underground, they're going to be those green boxes. Some of the green boxes are also switch points, but the green transformers that are underground, the gray cylinder transformers that are overhead, they're all doing the exact same thing. They're going to take one voltage and they're going to pump out another. They do this with induction, and they do this with different windings that are needed from your high side, your primary, to the secondary. So we can have 7200 come in. If we have the right ratio of windings in there, which is all done in the factory, we'll get 120, 240 coming out. That's our normal system secondary service to a residential home. We can have all sorts of different secondary voltages, 277, 480, 240, 480. We have just 120 loads, just 240 loads, different things like that. It's all dependent on what the member or the customer needs. One thing with the transformer I want you to remember is the way it was described to me was it's a big dumb animal. It doesn't care on the direction of flow, of current or voltage. All it does is it takes one voltage and it changes it to another. So remember this, we're taking 7200 and we're going to say we're going to change it to 120, 240. Now if I told you we pump 120, 240 in, what do you think is going to pop out the other side? Say it was wired exactly the same. We just reversed it. 7200. It's exactly what it does. That is an example of backfeed. And that backfeed is actually what we're going to generate and put onto our hotline demonstration, which is behind the curtain you'll see later on. That's exactly how we run our hotline demonstration up to 7200 volts. We pump in 120 and we're getting 7200 on this. So any of these arcs that you're seeing would reflect exactly that if there is a backfeed situation. All right? Moving down from the transformer, we have our secondary wire. This is going to be low voltage wire. It's going to carry your 120, 240 loads from our poles or our underground transformer to the houses or to that meter. From there, we want to talk about this too, this guy wire that comes down at an angle. Our guy wire is high tensile strength steel. It has absolutely no give, no stretch in that. And we get it fiddle string tight. And that is used anytime we need to put an angle on the pole, because roads aren't all built completely straight, right? You guys do a great job, but whoever designed it put some extra curves in there, right? And yeah. So we're going to follow those roads most often. And say we're going around a curve. And on that inside of on the outside of that curve, our poles are lined up there and we got an inside bend. We're going to need to counteract that force of our wire pulling in. And we use guy wires to counteract that force. They pretty much just they take that strain off of the pole itself and they put it onto this guy wire going down to a deep anchor. We'll pound anchors into the ground, we'll screw them in, and we can have 1, 2, 3, I've seen up to 4, actually no, we've had 6 on some poles depending on the angles. So these guy wires, what I want you to remember, because they have no stretch, they have no give, they come all the way down to the ground. If you had something pulled really tight, and then you cut one side, what do you think is going to happen to that other side? It's going to whiplash, it's going to have huge counteraction, and what can happen if that guy wire gets broken at the bottom, say a snowplow hits it, machinery hits it, even if it rots away, or farm equipment hits it, what will happen is that pole will see a massive shake, and you can actually have that pole break off in more than one spot. We got some photos of that later on. Moving on down, the lowest on the pole is going to be if there's any telephone or cable TV or fiber optic overhead cable on that pole. They have to maintain clearances from all of our energized equipment, so they're going to be the lowest on the pole. With that, phone and cable TV, that stuff's pretty weak. That cable is pretty weak. If you think of a coax cable in your house or something like that, you can break that pretty easy, right? Well, when they stretch it out from pole to pole, that's not strong enough to just put that weight and that strain on that cable alone, so they lash it to high tensile strength guy wire. That same stuff I told you that has no give. So we've seen this at our co-op where this lowest wire, this phone, actually gets hit by a piece of equipment that's just a little bit too big to go down that residential road. And what'll end up happening is it'll break the pole off right where it connects to our pole. They run a bolt through there so it secures it to the pole. We've had this happen numerous times. And we're a rural cooperative. If you can imagine it, there's a lot more of this in a city if you're working around there. So be keeping your situational awareness before driving underneath cable TV or driving underneath any wire, that you have your clearance. So for our overhead contacts, dump trucks tend to be one of our bigger ones. It's when they dump the load and they're trying to pull away with it, shaking it out, and they'll hook that lowest wire on the pole. You tend to see this too because if they're raising grade whatsoever, we had our clearances at one point, but if somebody keeps raising grade and we weren't really made aware of this, we couldn't go out there and make things higher to prepare. And it gets to a point where all of a sudden that load is now going to hook our neutral or the lowest wire, whatever's on that pole, just about every time. So we have had repeat offenders on the same stretch where they just kept raising the grade and weren't telling us, and next load they brought in, they dumped it, they pulled forward, they ripped our neutral down. I think it happened 4 times in a row before we were finally able to catch up with them and tell them, hey, you can't do this or we have to set new poles. Logging trucks and equipment, especially with the wood processors out there, they can whip those trees around pretty easy now. We've seen those get thrown into our lines. Cranes and backhoes, because of our rural area around here, we don't see as much crane work, but that is something when you get towards cities that cranes and backhoes are definitely, the potential of making contact is higher. Lifts, not so much with our utilities, our bucket trucks, our guys are pretty well trained, but the do-gooder on the weekend from the local rental, renting out a lift, a scissor lift or a sky lift, something like that, going home, trying to trim trees and getting into bad situations. We've seen that happen. Ladders, definitely aluminum ladders and electricity do not mix. There's some people that just don't want to spend a few extra bucks or carry that fiberglass ladder. We tend to see people not trying to work on our lines or on their secondary, but re-roofing the house, re-siding, stuff like that. Farm equipment, especially in the spring, it's going to be disking, plowing, planting, and then in the fall during harvest. Those are our 2 big seasons for farm equipment making contact with our lines. And then accidents. This would be car accidents, most likely. We've been pretty fortunate this winter, lack of winter, I should say, that we haven't had too many of these. We have had a few, but we've been pretty fortunate. Less and less vehicles have been sliding into our poles. So we've got a couple videos, we got a few videos here for you. The first one is going to be a crane actually making contact. So that's the outrigger arcing right there. That's its path to ground. For some reason it's arcing on that outrigger the most. So it's looking for any available path to ground. On this truck, it's finding multiple paths to ground. Now, if you were on that truck when it made contact, what would you do? What's that?
I'd get off of that.
You'd get off because of the fire? Right. We're going to show a video a little bit later, but you're exactly right. If there's a fire, if that vehicle starts on fire, it's no longer safe to stay on that vehicle. Rule of thumb, if you have electrical contact, say crane gets in the line, you hit a pole and there's power lines on your vehicle, rule of thumb is stay in that vehicle. That's the safest place. It's not until a situation where your surroundings have now become more hazardous, fire is about the only reason that you should have to exit that vehicle. All right, Ryan, you want to go to the next video? So the next video is this was an incident down in Florida.
Asthma you have, Dispire can help you have fewer asthma attacks and breathe better.
We're following breaking news in Fort Lauderdale where a crane has hit a high voltage electrical line causing an explosion. We know at least one person was hurt. Let's go now to Local 10 News reporter Joseph Ojo. He is live on the scene with the breaking details. Joseph.
And one person who was hurt and injured and taken to the hospital, they were lucky that a Fort Lauderdale police officer was on scene at the time because things could have gotten much worse. Just take a look at the scene right now. You can see all this debris that is littering the ground and some asphalt too as well that flew over to the other side of restaurants that was on the other sidewalk. And we are told that the crane operator hit an electrical line and this led to multiple explosions.
Gunshots at first?
Sky 10 over the scene of Southwest 2nd Street after Fort Lauderdale Fire says there were 3 operators working to remove an object from on top of the roof when one of the men on the crane hit a high voltage electrical line that threw him to the ground and causing 2 explosions.
Voltage lines, the FPL lines that it came in contact with are approximately 138,000 volts. The power then grounded out coming down through the crane into the ground where there was a gentleman standing next to the crane who was electrocuted.
Our cameras capturing the debris and asphalt that littered the ground from the explosion, and the back window of this car was blown out as a result of flying asphalt.
The asphalt and stuff that was under the crane just blew up and actually shattered my rental car across the street.
Battalion Chief Stephen Golden is crediting a Fort Lauderdale police officer who jumped into action as he prevented the operator who was injured from getting hurt even more.
That individual was transported to Broward Health in serious but stable condition.
All right, Ryan, you want to pause her there?
And there were 3 crane operators in total who were injured. 1 refused to be taken.
So, in these last 2 instances that we showed you, so this one especially, when he made contact, there's a big explosion, right? Asphalt was flying. It went to ground pretty quick. Now, I just want you to be aware, not every electrical contact with equipment is gonna have this big, obvious fireball or arc flash or explosion, something like that. There has been times where equipment's got into the lines and there isn't even a spark. So that goes back to your situational awareness, paying attention to where your crane is or your equipment is, your proximity to the lines, if you touched it. Because say somebody comes up and they touch that crane at the time you made contact. That is an example of touch potential. And the next video we'll talk about touch potential a little bit. But what I want you to think of here too is all that electricity is going into the ground. Now if you were standing near there, what do you think would happen? What's that?
You're going to start to tingle a little bit.
You're going to start to tingle. You're probably going to feel it. That electricity going into the ground and then moving out and dissipating is what we're going to call step potential. So if you have a crane get into a line and it doesn't even show any arcs or sparks or explosions or anything like that, you need to treat it the same as if you got into that line and you did see all of that. You need to treat it like it's hot. Our next video that we're going to show is going to go over, if you got into that line, how are you going to get out safely? What are you going to do?
Hi, I'm Bob Berry, and today we are going to talk about the touch potential and step potential hazards that may occur when operating cranes in the proximity of energized utilities. First, the best way to avoid these hazards is to follow the proper procedures for working near power lines. However, if contact with an energized utility does occur, it is equally important to know how to respond and avoid becoming a fatality. When a crane makes contact with an energized line, the machine and immediate area nearby becomes energized by potential energy. This energy is released due to grounding when a person touches the machine or steps into the immediate area, causing severe electric shock and fatalities. To avoid touch potential, never approach a crane or other equipment that has made contact with an energized power line. You may not see sparks, or even if the power cuts off, power lines may cycle back on several times when a fault occurs, prior to shutting off. To avoid step potential, always stay far away from the area immediately near a crane that has made contact with live power. Electricity conducted to the ground by the equipment creates zones of unequal voltage. As a person approaches the equipment, stepping between these invisible electrified zones causes the stored energy to pass through the body and find.
So what he's talking about here, this step potential, I want to sum this up a little bit more. He doesn't quite touch on this. So you think of those rings of potential. Think of throwing a rock into a lake. What happens? Get ripples, right? So what's the difference between those ripples as close when you throw that rock in to the ones that are furthest out? Are they as big of a wave? They start getting smaller and smaller and smaller, right? So that is rings of potential right there. That ring closest to it is not the same as the ring furthest away. And the difference is voltage. So this is all theoretical numbers here because I'm bad at math and I'm not going to do the actual math. Say we had 5,000 volts going into the ground over there. And then I'm standing in 3,000 volts right now. If I took a step and I stepped into 4,000 volts, how many volts are going through my body? 1,000. So that's the idea of those rings of potential. You're walking through different voltage. When you bridge a gap between one voltage to the next, you become the conductor. And that difference goes through your body. And that's where that electrical shock would come from. Like I said, all those numbers are theoretical. I kept them really simple because I'm bad at math. All right, Ryan.
Find equilibrium, shocking and killing the worker. A common mistake that often occurs after the equipment makes contact with the power line, workers investigating or attempting to rescue others also get electrocuted and killed, causing multiple fatalities. Even if you see another worker electrocuted, it is important to resist the instinct to run to their rescue. Always contact qualified emergency rescue services to handle the situation safely and avoid additional fatality. In most cases, the operator in the crane will not experience any electric shock and should stay inside the cab until help arrives. Attempting to exit the crane creates a serious step potential hazard. Only attempt to exit the crane if other life-threatening hazards such as fire present an immediate risk and staying in the cab is no longer a safe option. To exit the crane, jump with both feet together, landing on both feet. Shuffle to safety, being careful not to separate your feet or take a full step until a safe distance has been reached. Also, as a reminder, always be extra mindful of surroundings when working near power lines. Electricity often causes life-threatening injuries and requires extreme caution to work safely. And remember, proper planning, awareness of surroundings, and good communication always makes for a safe live. Look for our next Sims Crane Minute coming soon.
Back to the PowerPoint. Up. So, he showed how if you do have to exit that crane or that vehicle, then you have to jump, keep your feet together. So what's the difference of keeping your feet together or just taking a step? You're not going to be a conductor. You're not bridging that gap between voltages, right? I'm standing with my feet together in one voltage. If I keep my feet together and shuffle, keep them always contacting, I'm only going to be at one voltage. You'd be like a bird on a wire. They're not touching another potential. They're not making up, that difference isn't going through their body. They're standing at one potential. Another thing you can do, shuffling, is definitely the most conservative way. If you're young and nimble, not like myself, you can hop on one foot. You can hop away. If you're a little bit older than that, you can hop on 2 feet. You can hop away. But make sure, whatever you do, it's not just your feet you should be concerned of. You don't want to be leaning against anything else or touching anything else out there either. Because it's not just your feet. If I'm shuffling along and there's a tree off to my right and I lean on it, well, that tree could be at one potential and my whole body could be at another. So now I'm making myself a conductor again, right? So we need to make sure we avoid being that conductor. Don't bridge the gap between voltages. A few weeks ago we did this demonstration and I had a guy ask if there was an obstacle in the way, a tree was his example, tree trunk laying down, would I try to hop over it? I said the safest thing, because I don't know if you could tell, 5'7" here, I was never a basketball player. I don't know if you could tell, but I am not going to trust my vertical to make it over a log safely, unless it's a really small log. So I'm going to shuffle around that thing. I'm going to play it safe. Another thing, he talked about till you're at a safe distance, shuffling away. What do you think a safe distance is?
Somebody else is standing that's not.
That's exactly it. Where somebody else is standing and they're not being electrocuted. So you're working on a crew, right? You got coworkers out there. If you have to exit that vehicle and they're 20 feet away, 30 feet away, let's say even 100 feet away, is there a guarantee from where I'm at right now to them that there is no electricity in the ground there? Is there a guarantee? No. But the guarantee is I know when I make it to them, because they're safe. They're walking around, they're fine. I know that that spot that they're at is safe. I don't know between where I'm at now and where they are if it's safe. So I will shuffle that entire distance. It's about the only guarantee we could really give you. Because there's a lot of difference, and it's situational when you're talking moisture content, the voltage, the available fault current, how much is actually going into that ground and how far out is it dissipating. That could be different in every situation. That could be different from one spot of the job site to the other end. So use your guarantees. All right. So we also talked about direct touch. When you're working with your coworkers and they're near proximity of lines, are you going to be really messing around on that truck? standing on the ground, grabbing stuff off of it. It's not always a good idea. If they would get into that line and you were on the ground and that then went through you, that would be a touch potential. If those power lines came down to the ground and you walked into them, that's touch potential. Now we have protective devices out there, our fuses, our reclosers, things that operate, that open up the line. He talked about the line cycling back on. Who's seen their lights blink 3 times and go off at their house? Just about everybody, right? So that is a device we would call a recloser. And the reason why it cycles off and on is to let something that is having a touch potential clear. So rural Wisconsin, we have a lot of squirrels, raccoons, different things that climb up on poles, and they get into a situation that they get themselves electrocuted. So what happens is they touch it, and there's a let go threshold. If you there's a let go threshold with voltage or amperage. As soon as you get to a certain point, the body seizes up. It cannot let go even if it wanted to. Humans have a let go threshold as well. So that reclosure is going to cycle off. And the hope is that that critter loosens up, falls clear, and then when the power cycles back on, there's nothing bridging that gap between phase and ground. So then the lights can stay on. So it's a reliability thing. We size them for safety though too. We don't just throw the biggest ones out there. We want them to be reliable and safe. But they are going to cycle back on. And then after they go through their cycles, if it's still seeing that fault, they drop it, they dump it. There has been cases where something will touch a line, say it's metal, something makes a contact, touches a line, and it'll arc twice, it'll cycle twice, but on that second cycle of coming on, it burns away enough material that there's a gap now. Cycles off, comes back on, well now it's not touching. So now the line stays on. That can happen. That can happen if you get a piece of equipment into the line too. It can cycle twice, but you may burn something clear. So just because you see it spark, I don't care if you see it spark once, twice, 3 times, doesn't matter. Always treat that line that it's energized. Okay? So for our emergency procedures, stay put. And when wouldn't you stay put? Fire. As soon as it's more hazardous to be in that spot than to exit, that's when you make that decision to get out of there. You work in crews. We don't want anybody coming up and touching that piece of equipment when the lines are on it, right? What do you have in your equipment lots of times? Radios, cell phones, something to communicate to your crew to stay away. You want to keep your coworkers safe too, right? So tell them to stay away. Tell them to keep their distance. Contact help. You're going to want to let somebody know. You may not have your cell phone on you. If you got your radio on you, you can radio for help. Tell them what situation you're in. They can call 911. They can call the electrical utility. We will be coming out there. And if you're not able to stay on that equipment because of fire or some other situation, remember to jump clear. Don't touch that equipment. Don't touch anything else. And either hop on 1 foot or feet together, bunny hop, or shuffle clear until you make it to an area that you know is safe. And if your coworkers are fine 50 yards away, that's where you should make it to. That's a guarantee. This line right here, this was in the Wautoma area, I don't know, 6-7 years ago. This was in the fall during harvest. If you notice in the back there, combine is filling up gravity boxes. They never stopped working. And they are the ones who actually hit that guy wire down at the bottom. That guy wire that I said has no stretch and is a hazard because it does come all the way down to the ground. And if you hit that, you can do bad things. That's exactly what happened. This pole broke in 2 spots. Broke about 6-7 feet up there and also broke off the top here. That top was holding these pins. with insulators on top. That's how we secure that phase to the top. The reclosure, that protective device that's going to operate 3 times and then dump, was 2 poles down there that fed this. It was really close. It cycled twice because this was all bouncing. After that, the neutral was pulled off to the side and low enough that it didn't hit the phase. The phase wasn't touching anything else. It did not see a fault. And our devices need to see a fault to be able to work. So this line stayed energized. And it wasn't more than 10 feet off the ground. Definitely tall enough that any of that equipment down there could have drove into it again and there would have been arcing. And hopefully nobody would have got hurt. Luckily they stayed just far enough away from it that no one did touch it. And we came out there and we found it. So everything that we talked about overhead also lives underground. All the same hazards that we have with overhead also live underground. Are you going to have lines down if it's underground? Are those lines going to be laying on top of your car or your piece of equipment? No, they're not going to be on top. But guess what? If you run over a transformer or a switch point, anything like that, they could now be underneath. Is that going to be easy to see when you're in the vehicle or in the equipment? No. So keeping that situational awareness and knowing what devices are around you, transformers, switch points, we have underground regulators, underground reclosures, those things, being aware that they were there, if you would run into them and say you're parked on top of them, there is a likelihood that those lines are still energized. And a lot of that has to do with how the cable is actually constructed. And Ryan will show that a little bit more. When it comes to underground, there is some underground transmission, very, very little in the state of Wisconsin. Primary distribution, that's the bread and butter. Our system is now 70% underground primary distribution. Secondary distribution, that would be your 120, 240, 277, 480, different things like that. There's a lot more of that. And then private utilities, that would include anything from private water lines, slurry lines, pivot wires, different things like that. Before doing any digging, make sure you're calling Diggers Hotline. I really want to stress this. Dig-ins happen way more than they should. The same hazards, like I said, you have on overhead, you can have on underground. They should be treated the same. They're often not, but they should be. So never assume that you know where things are. Verify your marking instructions. Make sure you give the right area and that you give them the time to get out there and put that paint on the ground. For the different markings, most common 3 you're going to see in this area is red, which is power, that's us, yellow, which is gas, and orange, which is telecommunications. We do have lines that run parallel and cross each other all the time. So gas and power can be right next to each other. Question, do you want to dig into a power line and have a spark when it's parallel to a gas line? No, that sounds like a bad day. This is a prime example of somebody who didn't pay attention to their surroundings. This was what happens when an excavator runs over a 3-phase primary switch point. This switch point, which by the way, I'm just talking about this piece right here. This is a different device altogether. This switch point right here stands about this tall. It's about 6 feet long and about 2 foot wide. It was flat as a pancake when an excavator rolled over that thing. Our linemen did not get dispatched to this happening. They actually got dispatched to an outage because all 7 cables in here remained energized. This one termination we see right here, it's hard to see because it's dark against the dark background. That one termination popped off of a pad fuse sitting next to it, and that fed 2 houses. Those 2 houses out, that's what we got called to, and our guys show up and find this. Now imagine he had been parked on top of that and then exited the excavator. Could have been a bad day for him. Luckily for him, even though he did this, he drove down the road. He backed up, backed onto this, and then he drove down the road to his next job, which was really close. But all of this remained energized, except one cable. We got a little video for Diggers Hotline.
Okay, now I see why this mini Wi-Fi camera has been trending online lately. This thing is...
There are more than 20 million miles of underground utilities in the U.S. An underground utility line is damaged once every 6 minutes nationwide because someone decided to dig without calling 811.
He needs to get that house installed. I can't keep driving around it. Ah! We gotta get this one out of here.
I'll get it in this weekend, I promise.
Thank you.
Okay, thanks a lot, Carol. That's a heavy sucker. Oh, yeah. Bring up the big auger for this.
So you called 811 to get the utilities marked?
No, I didn't have time. Plus, wherever we're digging, it will be good with no electric or anything.
Well, you didn't seem pretty adamant to get me over here. I understand.
Yeah, the wife really wants to get done today.
Not bad at all.
What was it? Auger saving today.
I think first like a dream, I tell you what.
All right, let's grab some posts. All right.
Good, looks like the locator marked all the utilities. Sure does. Makes our job easier and safer.
Each excavation contractor working at an excavation site needs their own locate request. Excavators must contact 811 for a relocate if marks are destroyed or covered by excavation activities, or if excavation does not start within a period of successive days, depending on your state's requirements.
Keep going. Come forward, one more foot. A little bit more. Stop, you got it. What's the depth we need to dig the hole?
How's it looking?
Tommy, stop!
Treat all overhead and underground power lines like they are live. When a line flashes and stops, it does not mean it is de-energized. Lines can become re-energized at any time. If the equipment cannot be safely removed from the energized cable, you must stay on the equipment. Call the electric utility immediately to get the power turned off. Warn others to stay away from the area as the ground and equipment may be energized. Only render aid or assistance once utility personnel secure the scene and give you the all clear. If you are unable to stay on the equipment due to fire, jump clear of the equipment, making sure to land with both feet together and never touching both the equipment and the underground at the same time. Shuffle or hop away, keeping your feet together until you are at least 50 feet away. Never go further than toe to heel apart. Calling 811 to locate underground utilities before digging, and hand digging any time you are within 18 inches of a marked utility would have prevented these accidents.
All right. We can shut that off there. So remember to definitely call in your locates, but then verify your locates too. It's always a good work practice. Potholing, making sure that what they say is there is actually there. That'll help prevent a lot of headaches for you in the future. If you remember when I talked about the primary, phase, and neutral earlier, underground has the same thing, but they're actually tied together in the same cable. If you're doing any digging and you would skin the jacket, there's a chance that you're going to pull up these copper wires. These are our concentric neutral. We take a lot of small copper wires, it's wound around it, and then when we get to a termination, we bunch them all together, we twist it together, and it looks like a nice copper wire. That same hazard, if you broke that neutral and then would bridge across it, not only on overhead, it's also here with underground. So there's a chance if you would put your hand across that, you could become that conductor, bridging that gap from one side to the other. So if you do skin any cable, please never just try to slap electrical tape on it. It's a horrible thing. Just call us. We'll come out, we'll make the adequate repairs. So we got Mother Nature, generators, and renewables. So I talked about how we're going to backfeed our hotline demo. I just want to make you guys aware that even when our devices work properly and the lines come off, if somebody is impatient and decides to fire up a generator and try to backfeed their whole house, if they do not have the proper disconnects or take any precautions, they can backfeed with a generator through their meter, through the secondary line, into the transformer. And what did we say would happen if you put 120, 240 into a transformer? The other side's going to come out 7200, right? So that is an example of backfeed. Backfeed has actually killed lots of people. It has still happened in the state within the last couple of years that we're aware of, that a couple linemen have been killed from backfeed. So this is not something that's going away. It is something that we have to be situationally aware. If those lines, say these lines right here are down, you know, that looks like it's obviously off, right? But say Jim Bob down the road is growing impatient and backfeeds with a generator, all those lines could be energized and they could be right there next to the ground. So you could be walking right next to them if you didn't take precaution and stay away, and they could be energized. One thing with generators too, they don't have the same safety features that our systems have. So our protective devices trip at a certain amperage. We have seen this at hot labs where they will take a generator, they will backfeed the hot lab, so the generator's feeding it. They will take a ground, so they will short out from the neutral to the phase. And how fast do you think that tripped out? A couple seconds, I hear? Anybody else got a guess?
Are you talking about the power line tripping or the generator?
Well, the generator's feeding it, so that's what's going to trip. So how fast do you think the generator tripped out?
It's possible it didn't at all.
It's possible it didn't at all? Yeah. So what ended up happening, and I witnessed this in the lab, it took about 10 minutes for it to actually overheat before it popped its fuse. And that was a direct short in 7200. So what it did was, it just bogged down. It thought you plugged in about 6 more freezers onto that thing, and it just tried to pour the coals to it. So if you can imagine, if you went up and you would touch that line that's getting energized by backfeed, can you imagine getting electrically shocked for 5 to 10 minutes? It'd be horrible, right? So safest to say, no matter how bad it looks, always assume it's energized. The way our linemen protect themselves from that is actually getting open air. They go and they pull meters. They break the line where they can at open points. They open fuses, they open switch points, different things like that. Their only protection, their best protection is getting that air gap. that's their insulation. And then they'll test and ground that line. But they have to make sure they pull away any possible source of energy, and they take backfeed as a possible source of energy. So there's a lot of work going into isolating the line. So backfeed, it's out there, and it's not going away. You can buy a generator anywhere, right? So with that being said, Ryan's gonna come up here, and the fun stuff's gonna happen. He's gonna burn some stuff for you, all right?